folks, I posted this practice set of problems up in the in Schoology, but I wanted to go over the first one in detail with you. Again, the solutions are posted there, but I figured it might help some of you that are having a little more trouble with curve sketching. Some people are really good at it. Other people, like me, need a more measured approach. So I wanted to go over the first one with you, and we can certainly go over more if you want to. Just let me know, and we'll go from there. Okay, so I made this table to kind of organize, to help you organize your thoughts. As you can see, we're going to do the first derivative and identify our potential critical points, make a sign chart, right? From that sign chart, we can draw some conclusions about where the function is increasing, decreasing, where its mins and maxes are, all that good stuff. We're going to do the same thing with the second derivative. Identify our potential critical points, make a sign chart, and from that, draw some conclusions about where we are concave up, where we are concave down, and where we have points of inflection. Okay, once we do that, we're going to take all that information, put it together on a graph. All right, so for this function, negative x cubed plus 2x squared plus 2, my first derivative is going to be negative 3x squared plus 4x. Right? The 2 goes to 0. If I factor that, I can pretty easily see here that I'm going to have two places where it's equal to 0. It's going to equal 0 when x is equal to 0 and when x is equal to 4/3. This will be negative 4 and that'll cancel out. So I've got two zeros here, 0 and 4/3. Okay, now, as far as it not existing, again, it's a polynomial. It's never going to fail to exist, so I don't have to worry about that. So I have 2 points that I need to put on my sign chart. I need to put 0 on there and 4/3, which is 1 1/3. Okay. So I have these 3 intervals to test. Okay, so if I test back here and I put something like, oh, I don't know, -1 in, I get a negative here. I get -1 times 3 plus 4. So I get 7, but more importantly, -7. And all I care about is that it is negative. Okay. On the interval between 0 and 4/3, I can test something like 1. Then I'm going to get 1, -3 plus 4. I'm getting positive. And then after that, after the 4/3, I can put in something like x equals 2. And I get 2. It'll be negative again. Okay, so based on my sign chart, I can draw some conclusions. And one of the things I pointed out yesterday, and I want to point out again, is that if you are on the AP, they are not going to look at this, right? You can write all over this the way we just did. They're not going to look at it. What they're going to look at is the conclusions that we're going to draw down here, right? So you can see we have decreasing, then increasing, then decreasing. So it's decreasing, and then it starts to increase. Right here, that's a min. It's increasing, 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 and then here it starts to decrease. Right there, that's a max. It's also worth noting that this is a cubic. Right? I know the end behavior of this thing. It is a negative odd order. Right? So notice, from negative infinity all the way up to 0, it is decreasing. Right? So there is no absolute max. There can't be. This thing goes up forever. On the other end, it's decreasing forever. There's no absolute min. So I know these mins and maxes are going to be local, and I know that because of the end behavior of my function. That's an important thing to kind of add into this mix. So absolute mins and maxes, we know we're not going to have any because it's cubic. So my local min, I can see here, is going to be at 0. And my local max, I can see from my sign chart, is going to be at 4/3. Okay, now I can also identify my increasing and decreasing intervals. It's going to be increasing between 0 and 4/3. It's going to be decreasing everywhere else. So negative infinity to 0 and 4/3 to infinity. All right, if AP is asking me for this, again, they're not going to look at this. You could write decreasing, increasing, decreasing. They don't care. This is what they want to see right here. All right, let's do the same thing with our second derivative. All right, my second derivative, the derivative of negative 3x squared plus 4x, is going to be negative 6x plus 4. Nice linear equation. That's going to be 0 one time. I really just said that, and then I have a 0 in there. I'm funny. Okay. And by funny, I mean wrong. Okay. At x equals 2/3, this is going to be 0, right? So let me put my 2/3 in here. All right. It's never going to not exist. It's linear. Okay. So we only have 2 regions to test here. Let's test 0. When I put a 0 in, I'm going to get a 4. So if x is equal to 0, this becomes 0 plus 4. So this is positive all along here. And then if I go to the other side and I test something like 1, it's going to be negative. So we see we have a function that is concave up for a while and then switches to concave down. Because there's a switch here, we know that's a point of inflection. So when we draw our conclusions, we can say it's concave up from negative infinity to 2/3. It is concave down from 2/3 to positive infinity. And we have a point of inflection at x equals 2/3. Again, note, I did not include the 2/3, and you never, ever, ever put a hard bracket on infinity. All right, so all of this information is going to help us sketch a graph of this function. So we're going to take it 2 at a time. Some people can hold more information in their brains than others. And if you are a person who can hold both first derivative and second derivative information in your head, good for you. I cannot. So when I sketch these graphs, it's kind of a two-phase it's a two-phase process, and you want to make sure you're using a pencil for this. Obviously, I don't have a pencil on my screen here, but if you're doing this on your own, you will want to have a pencil because there's some erasing involved. All right, the first thing I do is look at my first derivative and make a rough sketch of my function, because my first derivative tells me increasing, decreasing, and mins and maxes. So I can draw a rough sketch of my function, and then I'm going to tweak it using my second derivative. Okay, so I know I have some critical points at 0 and 4/3. So what I do is on my grid, I put vertical lines in where my critical points are, and then I label my intervals. So I know that from 0 to 4/3, it's increasing. So I literally go in here and I write increasing in that little interval. Then I know it's decreasing here, and I know it's decreasing here. Wow, really? Okay. I know that I have a min at 0, so I'm literally going to write min at that line, and I write max at this line, so that as I'm sketching, I can kind of see what I'm supposed to be doing on these intervals. So based on, I also know I have no absolute min or max. In other words, it's a cubic, so I like to draw my end behavior in. On this side, it's going to go up, and on this side, it's going to go down. All right, so I need to start high and decrease. Once I get to this line, I need to hit a minimum. So notice I'm curving to hit a minimum. Now I need to increase for a while. I need to hit a maximum. And then I need to decrease forever. Notice this is a very rough sketch. Okay. You have no way of knowing from this information how high or low this graph is. That's beautiful. You have no way of knowing exactly how it's curved. It's just a rough sketch. Okay, now, based on this, I'm going to come in and look at my second derivative. My second derivative is going to help me kind of tweak this graph. So right now, this graph matches my first derivative. It decreases, hits a min, increases, hits a max, and decreases again. It's got the right end behavior. Good to go. So now I'm going to put in some new intervals. I'm going to do the same thing. Right? I have this point of inflection at 2/3. Okay, so I know that right here along this green dotted line, I need to have a point of inflection. In other words, this is the point where it needs to change concavity, right here. Okay, it needs to be concave up from negative infinity up to 2/3. So let's check and see if we did that. From negative infinity up to 2/3, I'm supposed to be concave up. And as you can see, what I sketched is indeed concave up. Okay, so I'm good to go there. It's supposed to be concave down from 2/3 to infinity. And notice I did an okay job over here. It's concave down. But you see right in here, this section I drew it originally as concave up. And again, all I was focusing on when I drew this was the fact that I needed it to be increasing. So now I'm going to tweak it. Instead of it being curved like this, I know now that my graph is supposed to be concave down there, so when I come up, I'm going to curve it differently. I'm going to curve it like that. So now I have my decrease, increase, decrease, and I have added in concave up on this interval, a point of inflection with a switch, and then concave down after that. So this is my sketch. Again, vertically, this doesn't tell us where things go. We don't know anything about the y values. Well, I mean, to be honest, we do, because this polynomial had I believe, a +2 at the end, right? So we could know its y-intercept, but we don't have any way of knowing how deep these peaks and valleys are, right? We don't have any way of knowing that. But again, all we're wanting is a rough sketch. So I have a picture of the actual function here. Let's see how we did. That's what the actual function looks like. Okay. Again, I didn't do too terrible. Again, the original function had a +2 at the end, so if I was being smart, I would have known that it needed to start somewhere, that I needed that point to be somewhere up here. But again, I wasn't thinking about that. Right? But notice, we decreased, we hit a minimum at 0, it increased, changed concavity right in here, hit a maximum, and then went down. We did a pretty good job. Again, my little my concave down part is much deeper than theirs. That's okay. We have no way of knowing how deep it is without looking at y values. But we did a pretty darn good sketch here to match this. Okay, so again, that's the procedure I use. Some people are able to look at their sign charts and say, okay, I need to draw decreasing and concave up and decreasing and concave down at the same time and keep track of all that. I just am not. For me, it's easier to just do a sketch with increasing, decreasing, and then make any adjustments that I need using my information about the second derivative. Okay. I hope that helps you. If you would like me to do more examples like this, I can certainly make more videos of examples. You just let me know. It is my pleasure to sit here and talk about calculus. I will see you soon.